Look at this rocket. It's taller than the Statue of Liberty, can carry over 100 tons, and is designed to take humans to another planet. This isn't just another launch. SpaceX's Starship could make Mars colonization a reality, permanently. Entire cities, ecosystems, and maybe even a backup for humanity could exist on the red planet. In this video, we're breaking down Starship, the technology behind it, and how it could make the dream of living on Mars a reality sooner than you think. Before we get started, if you want to see how humanity might become a multiplanetary species, hit subscribe. This is where space exploration meets reality. The biggest rocket ever built. Starship stands nearly 400 feet tall, taller than the Statue of Liberty. It's designed to carry over 100 tons of cargo, or up to 100 people to Mars in a single trip. No rocket in history comes close. The Saturn V that took us to the moon? Starship is bigger and more powerful. The difference is, Saturn V was one-time use. Starship is fully reusable. Both the booster and ship land back on Earth, refuel, and fly again. This is what makes Mars colonization possible. If every trip required building a new rocket, it would cost billions per launch. Reusability brings the cost down to millions. SpaceX already proved this works with Falcon 9 rockets that land themselves after launching satellites. Starship takes that idea and scales it up to a level never seen before. This is the vehicle that will carry humans beyond Earth permanently. This isn't science fiction. This is engineering reality. From explosions to success, Starship's development hasn't been smooth, and that's the point. SpaceX's approach is different. They build, test, blow things up, learn, and build better versions. Early Starship prototypes exploded on landing. Some didn't make it off the pad. Critics said it would never work, but each explosion taught SpaceX something new. Which materials handle re-entry? How do you land a vehicle this massive? You can't answer these in a lab. You test in the real world, and sometimes that means explosions. But they kept going. Each test got further, flights got higher, landings got closer to perfect. Now, Starship successfully completes test flights, landing both stages and proving the concept works. Traditional space programs spend decades planning to avoid failure. SpaceX fails fast, learns faster, and moves forward. That's why they're ahead. The explosions weren't failures, they were data. And that data is building the rocket that will colonize Mars, making humanity multiplanetary by 2030. Elon Musk has a timeline. Humans on Mars by 2030. A decade ago, reusable rockets sounded crazy. Now they land themselves routinely. The plan is clear. First, send cargo missions to Mars with equipment, supplies, and infrastructure needed to support human life. Solar panels, water extraction, habitat modules, everything astronauts will need. Then, send the first crew. Not to visit, but to stay and build the first permanent settlement on another planet. Mars has water as ice and carbon dioxide in the atmosphere. With the right technology, we can make fuel, grow food, and create breathable air. The first Mars colonists will be pioneers living in harsh conditions, working to expand the base. But with each mission, the settlement grows. More people, more supplies, more infrastructure. Within decades, Mars could have a self-sustaining city, a backup for humanity. If something catastrophic happens to Earth, our species survives. This isn't about abandoning Earth. It's about ensuring humanity's future. And 2030 is closer than you think. Terraforming Mars, turning red into green. The ultimate goal isn't just to visit Mars or even build a base there. It's to transform Mars into a second Earth. This process is called terraforming, and it sounds like pure science fiction, but the science is real. Mars used to have liquid water on its surface. It had a thicker atmosphere. Something happened billions of years ago that stripped away most of its atmosphere and turned it into the frozen desert it is today. The plan is to reverse that. Step 1. Warm the planet. Mars is cold because it's far from the sun and has a thin atmosphere. By releasing greenhouse gases, we could thicken the atmosphere and trap heat. This could melt the ice caps, releasing water vapor and carbon dioxide. which would warm the planet further. It's a feedback loop. As the planet warms, more ice melts, more gases release, and the process accelerates. Step 2. Create a magnetic field. Mars lost its atmosphere because it doesn't have a strong magnetic field like Earth does to protect it from solar wind. Scientists have proposed placing a magnetic shield at a specific point between Mars and the Sun to deflect solar wind and allow the atmosphere to rebuild. Step 3. Introduce life. Once there's liquid water and a thicker atmosphere, we could introduce microbes, then plants, gradually building an ecosystem. Trees and algae would produce oxygen over centuries. Eventually, you'd have a planet with breathable air, flowing water, and green landscapes. This won't happen overnight. It could take hundreds or even thousands of years. But it starts with the first boots on Martian soil. And that starts with Starship. Moon bases, the stepping stone to Mars. Before we colonize Mars, we're going back to the moon. And this time, we're staying. NASA's Artemis program plans to establish a permanent base on the lunar surface, and Starship is a key part of that mission. The moon is only 3 days away from Earth. Mars is 6 to 9 months, depending on the alignment of the planets. That makes the moon the perfect testing ground. We can practice building habitats, mining resources, and living off-world without being so far from home that rescue is impossible. The moon has water ice at its poles. It has metals and minerals that can be mined. It has an environment harsh enough to test our technology, but close enough that if something goes wrong, help can arrive quickly. A moon base also serves as a refueling station. Starship can launch from Earth, stop at the moon to refuel using resources mined there, and then continue to Mars with a full tank. This drastically reduces the cost and complexity of Mars missions. Plus, the moon offers opportunities for science and industry. Helium-3, a rare isotope that could revolutionize energy production, exists in large quantities on the lunar surface. Mining operations on the moon could fund further space exploration. The moon isn't the final destination, it's the proving ground. It's where we learn to live and work in space before making the giant leap to Mars. Why this matters for everyone. Why spend on space when we have earthly problems? Space exploration drives technology. Apollo led to satellites, computing, and clean water systems. Mars missions will bring even bigger advances, better life support, food growth in harsh conditions, and sustainable habitats that help Earth. Beyond tech, humanity needs big goals that unite and push us forward. Staying on one planet is risky. Asteroids, pandemics, climate disasters threaten us. Becoming multiplanetary is our insurance for survival, and it's happening in our lifetime. What makes Starship legendary isn't just its size or power, it's the vision. A rocket capable of taking humans to another world, changing the future of civilization forever. But the journey won't be easy. Space is unforgiving, and colonizing Mars will take decades of innovation, sacrifice, and courage. So tell me, would you take the first flight to Mars if given the chance? Or is humanity safer staying on Earth? Drop your answer in the comments. If this video gave you a new perspective on interplanetary travel and Starship's role in our future, don't forget to like, subscribe, and share it with someone who dreams beyond Earth. Thanks for watching. I'll see you in the next one.